So for this video, we're going to try to interpret a velocity time graph and just try to understand what is trying to be communicated in it. So that this is the question. The graph shows the motion of a ball when it's thrown upwards in the air. So we're throwing a ball upwards in the air, somewhere up into the sky. Then what happens? Until it hits the ground. So, okay. Find the height above the ground from which it was thrown. We've got the velocity time graph right there. Right there, we've got the velocity time graph. So we need to remember that if we're thinking about distances, or height is just like height is a distance, we're gonna be considering areas underneath a graph. This is area underneath a graph. So let's see. So in the positive part, the ball might be going upwards, right? And in the negative part, the ball is going downwards. So let's think about this carefully. So this area up here shows the distance that the ball goes upwards. So the ball goes upwards maybe 10 meters, right? And then the area down here shows when the ball was coming back down. So here is where it was thrown. So it was thrown somewhere there and it went 10 meters upwards. And then this area down here shows how far it fell back down. So if it fell back down another 25 meters, that tells us that it was actually thrown 15 meters from the ground, because it went up 10 meters into the sky, then it fell all the way back down 25 meters. So 10 plus 15 is 25. That means you are standing 15 meters above the ground when you threw it. And that's the idea we're going to use to think about this whole question. Let's see what next. Okay, let's just draw here like that. Okay, so now we can start on our thinking about this. So let's try to see if we can calculate the area in the positive part when the ball is moving upwards. Let's see. So the area, this is just a triangle, and we've got 10 and we've got 1. The area will be a half times the base times the height. So a half times the 1 times the 10, which will give us 5. So this area right there is 5. So that tells us that maybe you're at a window, you threw it up 5 meters. Now we need to figure out what about when it was coming down. How much did it cover? So we need to find the area of this triangle down there. Well, but we have the height of this triangle. If you can see carefully, the height is 15. But we need to figure out what this base is. We don't know what that base is. So let's try to figure out. We're going to use the Seurat equations for that. So the first thing we want to do here, just write down Seurat. So I want to figure out the area of this bottom part. We know that the final velocity seems to be negative 15. Okay. And the initial velocity, what's the initial velocity right there? It starts out at a speed of 10. We can consider this whole line. We can consider this whole line partly because from 10 all the way up here up to 15, it's a straight line. And the line, if you have a straight line, you have a constant gradient, and that means you have a constant acceleration. And so these equations, which are the equations of constant acceleration, should work throughout the whole path that you have a straight line, unless the line starts to change direction or to change gradient. Now what else can we figure out? Can we figure out the time for the whole path? No, that's what we're looking for. Can we figure out the displacement? No, we also want to find that later. So we can try to figure out the acceleration by looking at this first part, the first part there, right there, from 10 to 0. So what happens here? Can we figure out the acceleration of this part of the graph? So that's the velocity, that's time. So in this part of the graph, we have the starting velocity 10 and the final velocity 0, and that happens over time 1. So the ball starts from a velocity of 10 and then it goes to rest. We say that will be the maximum height. When it goes to rest, that will be the maximum height. It will reach the peak, stop moving, and then come back. So it goes to rest and it takes it 1 second. So we can calculate the acceleration here. Acceleration is equal to final velocity minus initial velocity over time. So what's the final velocity here? 0. For just this first part, the small first triangle, minus 10 out of 1, which will give us minus 10 as the acceleration. And this makes sense because this is the acceleration of gravity, and this ball is falling under gravity. So the acceleration for the whole duration is minus 10. So we can now sub that into our equation. So okay, minus 10 is our acceleration there. Now we can figure out the time quite easily. So t is equal to v minus u over a, which is equal to minus 15 minus 10 over minus 10, which is equal to minus 25 over minus 10, which is actually equal to 2.5. The time here is 2.5 seconds. So now that's the whole time, all the way from here to there. But we just don't want the whole time. There's a specific section that we want. Let me just make this a little bit cleaner. So we already got this area here as 5, and we've gotten this whole time as 2.5. But I want to subtract 1, so we have just that part. This part will just be 1.5, just that section there. Time here is 2.5, but the base of the triangle there will be 1.5. And then the height, we already have the height, it's 15. So we can also calculate the area down there. So it'll be a half base height. So a half base height, a half times 1.5 times 15, actually times negative 15. 0.5 times 1.5 times negative 15, which is negative 11.25, and that's the area down there, negative 11.25. So let's clear this and put it right there. So negative 11.25, like that. Now we've got the upward displacement and we've got the downward displacement. So let's go back to our diagram. So we said the ball goes up 5 meters from where you threw it, and then it comes back down 11.25 meters, the negative part. So it'll be 5 minus 11.25, which is 6.25 meters. And that will be this part right there. 6.25 plus 5 is 11.25. And that shows you that you are 6.25 meters above the ground when you threw the ball. And that will be how you do this question.